Alan is a 25-year veteran of the networking industry and has been with Cisco for 17 years. He's currently the Senior Director leading IPv6 High Impact program for Cisco across all product lines. Alan and his team are at the very core of this massive industry transition and directly involved from definition, standardization, to delivery of the technology and architectures underpinning IPv6 transition, along with the technology development and product engineering groups across Cisco. Most recently, Alan led Cisco efforts to support world IPv6 launch activities, both for Cisco itself and its customers. Alan was one of the first CCIE in 1992.
Thank you. Thank you. And some of this stuff is pretty old. I want to start the presentation by saying that some of the technologies that you guys talked about at BC Hydro, I was actually involved in developing them, or at least some of my team, RIPL and MAP and stuff like that. So it was quite rewarding to see that on the slides. I didn't even know about it, so it's even more interesting. You're going to make me blushing now. So what I'm going to talk about here is essentially three different aspects of IPv6. The first one is we all talk about IPv6 adoption, happening in various parts of the world. One of the first things we did when we actually created the IPv6 High Impact project at Cisco was measuring IPv6 adoption, because, to be very honest, I was tired internally of going into arguments about anecdotes of my customers does that and my customer don't do that, and this one is deploying it and this one is not deploying it. So I said, look, the only way to make business decisions is to base them on data. So let's collect data, aggregate them, show them on an ongoing basis, and then we're going to be able to make intelligent business decisions, hopefully, based on those data. So that's one of the first things that I'm going to talk about. The second one is now we've collecting this data for a few years now, and so we think that we have some pretty good insight into forecasting what is going to happen a little bit. We've been doing that for quite some time, and it's actually working pretty well. I'm actually pretty happy with the forecast that we did about a year ago or 2 years ago. They tend to be pretty accurate in terms of what's happening and where it's happening. And the last, the second part of the presentation is going to be more about performance measurement. We've been talking about V6 and V4 being deployed. Okay, but how does that feel for an average user in the field? When they get to Google or get to Facebook over V4 or V6, most of the time they don't know which protocol they are using by design. But we also don't want that the performance would be better, or even, we would like the performance to be better on V6, but is it really the case, and why is it the case? And what are the performance comparisons between V4 and V6? And the last part of the presentation, I'm not going to talk about it now, but I'm going to go back on some of Tom's comments this morning about finding new business cases for IPv6. I'm going to give you a few examples of what we are trying to do with something that we call IP-centric, and we'll see that at the end of the presentation, and then we can go into Q&A. So the whole idea of developing a 6-lab measurement platform is kind of encompassed into this code, right? A lot of people talk about, the world is going to fall over, and, every time there is a CGN going belly up or a regional registry not having IPv4 address, so there is a lot of noise about it. But nobody talks about the silent growing of the IPv6 forest. So the 6-lab website is that. It's the sound of the forest growing. You can see it that way. There are a couple of ways you can get to that site, either mobile or on your browser. And you're going to get daily a snapshot of IPv6 adoption. It's actually updated every single day. We collect, collapse, and compute a lot of data, and we just display it on a daily basis. And we tend not to change much what we are displaying, because we want to have kind of a continuum so people can measure the progression over time. So we have a lot more stuff that we are not displaying yet, which I'm going to talk about. But the displays are actually pretty consistent, and have been pretty consistent for the last at least couple of years, right? As I said, the best way to foster deployment is really to measure how we do, good or bad. In some cases, pretty bad. In some cases, pretty good. And just benchmark how we're doing at the country level. This has been a very good way of engaging with, government regulators, large service providers. If you start showing them data on what's going on and explain why this is growing that way or that way or that way or that way, then it gives really good insights, and we have productive conversations most of the time. And the same thing goes with vendors. The same thing goes with regular enterprise customers. So basically, we've been measuring data in multiple areas, and we've been looking at what's going on when a given customer has an IPv6 deployment project, right? So first they go through a phase of planning, obviously. Then they go through a phase of turning on networks. Then they go through a phase of turning on content. Then they go through a phase of turning on users. Sometimes it doesn't happen in those orders, but most of the time it does. And so we tried to pick up few metrics that represent each of those phases. So in the planning phase, for example, it's fairly easy to look into the regional registry databases and find out how many prefixes have been assigned in a given country, how many of those prefixes you find in the routing table, and even how many of those prefixes are sending or receiving traffic. We have ways of measuring that we plug ourselves into the peer-to-peer networks, for example, and we see, what are the prefixes and the networks that can actively send and receive traffic. If you measure that over time, that gives you a pretty good indication, because usually when you get a prefix assigned, it takes about 2 years on average to turn on that prefix into something useful, right? A given customer takes quite some time to do the planning and turning it on. So you can almost forecast that if you had so many prefixes assigned in a given area, 2 years later, those prefixes will turn into active networks. And so if you measure that over time, you can basically forecast, how many of these networks will turn on V6, right? So that's one example of what we do for measuring the folks that are in the planning phase, right? And when do they move from planning to deployment? Then we look at the network. So obviously, as Tom said, there is absolutely no way, or no easy way, at least, of measuring what's happening inside of an enterprise network or inside of a data center network, for that matter, right? Nobody can tell what's happening inside of the Facebook infrastructure. What we all know is that they provide V6 to the end users on the front end, but what do they do internally? There is no way of measuring that. But for the public internet and what is facing the internet, there are some really good ways of measuring this. I mean, you go into the route view database and you can actually extract a lot of very useful information, both V4 and V6, right? And so we've been measuring that. We've been measuring what is the state of the transit system, for example. How many of the transit advanced autonomous systems have turned on V6? What is the congruency with V4? And so on and so forth. And not every transit AS is equal on the internet. Not everybody is born equal. There are small ones that are at the periphery of the network and big ones that are in the center. And it's actually, some of them have more importance than others in terms of turning on V6 on the global transit system. So we've weighted those, right? And we are measuring when V6 is turned on. Is it turned on at the periphery or in the core? Is it useful for the bigger community or just useful for the people connecting downstream to a relatively peripheral autonomous system? So all of that is encompassed into the metric. Then we are measuring content. And so this one is actually an interesting one, because it's actually very easy to look at the DNS database and find out how many Quad A records you have in it. But that doesn't tell you anything, right? Because my personal blog, or Eric Vinke's blog, who is a famous member of the team, is V6 enabled. Okay. Is there a lot of traffic and a lot of users going to those sites? No. Okay. However, I mean, it's a Quad A record. I mean, it's equivalent to a Google Quad A record. But as you can imagine, from a user experience standpoint, the number of clicks and unique visitors going to Google is not the same as the number of clicks and visitors going to ericvenk.org. So we've been trying to weight those. And so the the best way that we found, it may not be perfect, but that's the one that we found, is look at Alexa. Alexa.com is actually doing a pretty good job at collecting statistics on websites, ranking them, right? And they can even tell you through an API how many clicks and unique visitors per websites per country. So we went into Alexa, and every day we're basically going and, well, actually, no, we don't do that every day, but we do that from time to time. We collect the top 500 sites in 130 countries. And we know, if they're ranked number 1, 2, 3, 4, down to 500. And by doing some interesting computation, we know that number ones, for example, represent about 15% of the clicks in a given country. Number 2, it's 12%. Number 3 is 8%. Number 4 is 4%, and so on and so forth. You basically have a Pareto regression. And the number, once you've passed number 30, each and every website represent 0.1%, and then it's 0.001%, and so on and so forth, right? So we have that Pareto law compute. We basically have probes. We're testing all of those websites every day. We do HTTP gets and compare between V4 and V6. And if the comparison of V4, V6 HTTP get is within 80% similar, we basically, and if they are number 3 on the graph, we know that number 3 equals 5%. If they are number 15 represent 0.2%, whatever the number is, right? You sum that up, and for an average German customers, because we test the top 500 sites for German customers, that for an average German customers, they have 46% of the content is available on V6. And it's real content. It's actually clicks, activities. It may not be volume of traffic, obviously, because the Google web page is actually much smaller than a Yahoo web page. But, in terms of activities, unique visitors, clicks, it's actually 46% of the internet activities in Germany are actually over IPv6 for an IPv6 connected user. Right, so that gives a pretty good indication of how much is available content-wise if you were to enable your users to be on IPv6 in country X, right? And I can do that for 130 countries around the world. Once you have the content, what happened with the users? Well, users, I don't have any ways of measuring users, but Google and Facebook and Yahoo do. So I basically, and Appnik has a very clever and very smart way of measuring user penetration. So I'm relying on those people's data and just collecting those data and displaying them country by country. Just to give you an idea of what Appnik is doing, which I think is very, very smart. They've actually embedded, they're actually publishing fake advertisements. And those fake advertisements are actually, small images in which they have embedded Java code. And so if you go to, let's say, a Yahoo website, there might be a print of a very small ad, which Appnik is paying for, by the way. You don't have to click on that ad, but that ad is basically trying to connect to an IPv6 only site and a dual stack site, and is measuring the proportion of successful connections that they achieve. And by collecting all those data from the ads, they have millions of prints that they collect statistics from every day. It goes into every browser. It goes into mobile browsers as well. So they actually have a pretty good view, of what, how many users have IPv6 connectivity active and working, right? Not capable, active and working, end to end. So we collect all of those and we display them on the website, okay? So what do we get? And those are actually a few weeks, I took those snapshots a few weeks ago, right? Because I had to deliver my presentation on time, which I didn't, but I did my best. So let's look at the internet core. So these are the network metrics, right, on the website. This is actually available on the website if you go. So on the left, there are two representations of the same thing here, right? But I think it's important that you understand those two graphics. On the left side, you basically have a representation. Every dot on this circle represent a transit AS, not a peripheral AS. Okay, so it's an autonomous systems that have a downstream neighbor in the routing table. Okay, these are the only ones that I'm interested in, really, because, frankly, if you are a peripheral AS, you don't provide transit service to anybody, you just provide content or users. That's good for you to be on IPv6, but it's not good for anybody else. If you're a transit AS, it's good for all the ASs that you're connected to, right? You can provide transit paths to. So I'm only representing transit ASs. There are 11,000 transit ASs with IPv4 in the global internet. Well, they were a few weeks ago. It changes all the time. And then I'm measuring how many of them have IPv6 or IPv6 enabled. So there are, 4,000 something IPv6 enabled, not providing transit service for IPv6. What does that mean? That means that they don't have transit, they don't have downstream neighbors for v6. They may have downstream neighbors for v4, but not for v6. But they have IPv6 enabled, so they're ready, right? If you send them a packet, they know what to do with it. And there are 1,900 of them that are actually transit for v6 as well as v4. So those ones not only are ready, but they carry traffic, they have downstream neighbors, they provide service to downstream ASs. Now, when you look at those numbers, it's a relatively small percentage. What is more important is where are those transit ASs? It's more important that they're in the core than at the periphery again. So how do we measure that? Well, we're basically looking at the table, and we look at how many networks a given transit AS, a given transit AS number is in the path of networks. And based on that, we evaluate, how core they are. We assign a weight, if you wish. And we place those transit ASs on the map based on the number of networks they provide transit service to. Yeah? So I hope I'm making myself clear, and then we rank them. So if you look at the center of that circle, that's the top 5%. The top 5% is about something like 300 ASs, actually a little more than that now, probably more like 500 ASs. Those 500 ASs in the core are providing transit service for 95% of the internet, right? So if I'm chopping up, in small chunks like you have on the right slide, the top 20, 100% of them are providing transit service with v6. The top 50, it's 92%, if I remember correctly. So you go down basically the list. As you can see, there is more work to do in the periphery of the network, but the very core, the top 300, even the top 1,000s, are very, very ready for v6. Yeah? So there is work to do to turn on v6 on those peripheral ASs, but the one in the core are pretty good. So if I'm looking at country by country, I now have a percentage of the in-country transit system and how ready it is for IPv6. And here I'm only looking at autonomous systems providing transit service for v6, not having just v6 enabled, right? So they have downstream neighbors. So you can see that the US is actually pretty low, and there is an explanation for that. If you look at the number of transit ASs in the US, it's probably 100 times more than in the UK, or as an example, right? Or any of the European countries. I mean, the number of the transit system in the US is way more developed than it is in any other regions. Why? Because a lot of university and research networks, a lot of regional backbones that are providing transit services, a lot more than anywhere in the world, really. In a lot of places in the world, you have, a very small number of very large ISPs providing services to everybody, right? So percentage-wise, it's a lot easier to turn on v6 on 100 autonomous systems than on 10,000, basically. Yeah. So don't feel too bad about the 60%. That's the message. They're actually the good 60%. And there is work to be done for the others. So I'm sure there are some in the room here. But you look at countries like Norway, Sweden, Netherlands. Look at this. I mean, of course, the absolute numbers of ASs is smaller, but still, I mean, they have like 91% in Norway, right? You can't get any better than that. Because probably the ones that are not enabled will never be enabled. There are, things have sedimented there, right? And they probably not going to turn it on because there might be old networks that they don't want to turn v6 on. So I'll just give you an idea, right? Greenland, by the way, there's only one AS there and it's not enabled. Interestingly enough, there are some countries where you have 100% Cuba is one of them. There is only one AS there, so they turn it on. Job done. And there are a few examples like that, actually. I'm just picking, Colombia is another one, actually. I think there are two. Anyway, now let's move on to the content, right? So the network is in good shape, right? I wouldn't say 100% ready, but in really good shape. And by the way, that hasn't happened by luck, right? This has happened because of a lot of hard work and blood and sweat, right? So congratulations to the people who've done it. It took them a long time, but they've done the work. So something to recognize. Now, let's look at the third metric, which is content. So I mentioned earlier this Pareto regression that we computed based on Alexa data. So we know the rank of a particular website in a particular country. We know how many clicks and unique visitors, and with this, we've actually computed this Pareto law, right? So we know that if you're number one, as an estimation, you represent about 15%, number 2, 12, number 3, 8, and so on and so forth, right? And then you have a long tail. I'm not measuring past 500 because that would be useless, right? It doesn't add much. Now, you look at the US, for example, as last time I took the snapshot, it was a few weeks ago. Actually, that was right after LinkedIn turned it on. So LinkedIn is in, okay, in my stats. I paid attention to that. But if anybody turned it on after LinkedIn, they're not on this slide. But they're on the website because the website is updated every day. So in the US, 39 sites among the top 500, representing 46% of the activity. I shouldn't say traffic because it's not really traffic, right? But when you have people like, Google, Facebook, Wikipedia, Yahoo, Netflix, and so on, YouTube, all turning on V6, the 10% users that Tom mentioned in the US that goes to those sites, they spend more than 50% of their time on IPv6, right? They don't know that, but that's the reality. And as you can see, the pictures varies greatly. So interestingly enough, in most of the European countries, among the top 10 sites, you have the top 10 sites of the US. You have Facebook and Google and Yahoo and those sites, okay? They are part of the... But you also have a bunch of other sites that are not in the US, like the local service providers. Deutsche Telekom email or Deutsche Telekom homepage is actually a very popular one. You have the local banks, you have the local, e-commerce websites. eBay is not in the top 10 in Germany, for example. They have an alternative to eBay. So we're measuring those. And as you can see, in some of the countries, look at Czech Republic, 80 sites among the top 500 for Czech Republican users. And that's about 62%, so on and so forth, right? Most of the time when you have these, bigger numbers is because you have a couple of hosters that have turned on V6 on behalf of their users, right, on behalf of their websites. And so as of a sudden, in Czech Republic, for example, all of the press and medias are all on IPv6 because they hosted into two different web hosting companies that have decided to turn on V6 by default for all of the websites that they host. And that makes a big difference, right? Same thing in Brazil, same thing in a few countries like that. The other thing that was interesting is when... So about 50%, right, in US and most of the European countries. Actually, there is one thing that I want to say here, China. So China is an interesting beast. Japan as well, by the way. So Japan, there are actually a lot of users on IPv6 in Japan, but very few of the US global websites, let me put it that way, are actually in the top in Japan. Therefore, Google in Japan is not that important for the Japanese users. And the Japanese equivalent haven't necessarily turned IPv6 on. So you have the same sites, but because they're not in the top 10 or the top 20, they represent a much smaller proportion of the traffic, right? That's the reason why you have 25%. For about 36 sites, you only have 29% in Japan. China is way different. In China, the only network that has really turned on V6, for end users is actually the CERN, which is the research and education network in China. None of the commercial ISPs have turned on V6 for internet access. They are using V6 for delivering voice and video, walled garden services, which obviously we cannot see here, right? But for internet access, they haven't turned on V6, and the reason is very simple. The country firewall is not V6 enabled. Okay, so the government-controlled web infrastructure is not V6 enabled, and so none of the commercial ISPs will be authorized to turn on V6 until that is done. Okay, as a consequence, none of the big content guys are turning on V6. So the few that have done it are relatively low in the rank, and most of the time, by the way, if you go to V6, you get to a different page. Okay, which talks about V6, but it doesn't talk. It doesn't give you the real content. Okay, so just be aware. That's the reason why China is red in most of those maps, although that would be a country that would need it a lot. But I think when the country will decide to turn the switch, I think you're going to see a big increase of users, but they haven't decided to turn it on yet. Yeah. Now, this being said, well, let me finish on the content first. So, summary, about 50% of the content is reachable over V6, not 50% of the websites. By the way, if you look at the total number of, if you go in the DNS databases, about 12% of the Quad A record of the records are Quad A enabled, 12%. But a lot of small sites basically, right, which doesn't necessarily show in the content. Local content is missing. So what I mean by that is local banks, local insurance company, local healthcare, local, you go in Italy, in Spain, in France, in Germany, or in Switzerland. I mean, the big guys bring IPv6 content into the country and through caching, but the local company haven't enabled it yet. Okay, they need to wake up because it's a lot of education. Actually, they need to wake up because in some of these countries, the percentage of users is actually quite significant. We're getting into 30% in Belgium, for example, 12% in Germany, over 10% in Switzerland. So there are some countries where users are showing up. Cloudflare was actually an interesting, end of March last year, Cloudflare decided to turn on V6 by default on every pages that they were hosting and accelerating. Well, guess what? This has shown on the statistics, plus 1% on the global scale. And in some countries, it was basically the totality of the IPv6 enabled content was actually provided out of Cloudflare. So as of a sudden, I saw Tanzania showing up, Kenya showing up, and countries like emerging countries like this, because most of their content is actually hosted somewhere else, right? Not locally. Right? But nevertheless, I mean, for the local users, it counts. I mean, it shows. So I'm not going to talk about that again. You've seen this. Tom provided us with the same. He had the luxury of presenting first, so he got he broke the news. That's fine. And mine is old anyway, so let's move on. However, one thing that I'm doing that Tom hasn't done is I'm using those and I'm forecasting, right? So one of my team member, Eric Vinke, have actually came up with the help of some folks from Google and other places with a way of, an interesting tool. You can basically go into his website, you have the link here. You enter your country, you will see the number of users from, collected by Google, the actuals, number of users. And you can, based on the shape of the curve, you can decide how you want to project yourself, the kind of regression that you want to use, exponential, polynomial, whatever you may want. You decide the one that fits the shape of the curve, and then you project in the future, right? So you can project a few months, a year, you decide the number of days that you want to project in the future. It's pretty telling. And you end up with things like that. So I've used Germany and the US just as two examples because I want to show you something interesting. So the US is the purple line and Germany is the green line. So Germany, there are basically two very large ISPs in Germany turning on V6 by default on every new subscription on cable, DSL, and fiber, right? And they've been doing that for about 18 months now. And they went from 0 to 12%. Actually, Deutsche Telekom, just to give you an example, is adding 12,000 users every day, right? They reboot 12,000 residential gateways, and they load the new config and you get V6 by default. So you have a pretty significant ramp. It's growing. US is actually growing nicely as well. But when you project into the future based on the past couple of years' data, this is what you end up with. So in a year from now, we should have 25% of the internet population in the users on IPv6, and in Germany, a little less than 20%. Why that? Any guess? Mobile, right? In Germany, the only ISPs turning on V6 at this point in time are, DSL and cable. The churn, the number of users that they enable every day or every week is actually pretty significant, but it's nothing comparable to the number of people buying a new smartphone from Verizon Wireless or T-Mobile, right? In the US, the mobile operators have turned on V6 by default on every new Android, 4.3 devices that you bring online, and that shows on the projection. It clearly shows. T-Mobile was able to get to 20% of their end users in, 9 months, very, very quickly. So thanks to Apple and Samsung and everybody else doing, pushing you guys to buy the new shiny phones. When you buy shiny phones, you get V6 by default. So those projections are actually interesting because they show you that depending on how you deploy V6 and who is deploying V6, the growth curve can be dramatically different. Oh, there is another interesting parameter in this is, do you manage the residential gateway or do you don't? Right, in Germany, they manage 100% of the residential gateway. So when you get a DSL line, you get a router with it. When you get a cable subscription, you get a router with it. So turning on a feature is actually under their control, not under your control. In the US, you buy your router at Best Buy. And whether you turn it on or not is down to the end user. Some of those boxes have V6 enabled by default, but if they don't, if the average end user does not turn on V6, and they're very unlikely to do it because they don't know what it is, Comcast can do everything they want to turn on V6 on 100% of their cable subscriptions. If the router is not enabled, it's not enabled. Yeah, so that makes a difference in the how you're growing. So this is about stats, actuals, what we've collected and what we could potentially forecast. So great, there is content out there. There are users coming online. Should we go back to sleep? So last spring, I had a couple of interns in my team, which I asked them to work on, tell me how those users feel about V6. It's one thing to have V6 enabled, but is it better or worse? Are users going to turn off V6 because they feel like the performance is not good, right? So that's, I think, is very important to measure if we can. So we decided to embark on a campaign of measurement, of performance measurement this time. So we basically deployed a few VMs in a few places, right? Dual stack VMs in North America, in Europe, in Asia Pac, in Australia, from various providers. By the way, a little bit of commercial. I mean, those guys have V6 enabled, so you can buy a VM from those people with both V4 and V6 by default without asking anything special. We basically did, the probe that we were doing were pretty simple. We were doing HTTP requests on the top the top 1,000 from Alexa plus another 10,000 from randomly selected from 6E database, right? So it was a mix of very big sites and just average websites, some of them being very small. We collected those stats. We measure RTT, right, the time it takes to open an HTTP page, a TCP session, sorry. And we collected those stats into a big data Hadoop database, did some crunching numbers and look at TCP dumps and filtering and eliminating a lot of crap out of it. And we basically net. I mean, there are a lot of other stuff, but let me cut it to the chase. The net is that in the vast majority of the cases, performance of V4 and V6 are identical. This is big news, guys. You should be cheering. You know, V6 is not worse. V4 is not worse. Most of the time, it's identical within 100 milliseconds. So basically, the end users can't tell the difference, right? And that's true for the vast majority of the sessions. Okay, so then the interns were actually pretty disappointed because they didn't have anything to do. They say, okay, so it's the same. So what? Not going to put that on my paper. I'm going to get a bad grade. Said, well, look, let's look at the anomalies, right? The thing that we should be really looking at. It's actually interesting to see the distribution. There are almost as many anomalies on V4 that you have anomalies on V6, right? There are almost as many cases where V6 is better than cases where V4 is better. Yeah? So let's do a deep dive on the anomalies. So we did a few things. We actually relied on the RIPE Atlas probes. I don't know if you guys are familiar with that, but RIPE Lab is distributing for free small probes that you can connect in your network. They have, you know, I don't know how many, but a lot distributed everywhere. And those probes are actually great because they provide you a way. You can select the probes. I mean, they have the tools. They gave us access to the tool and the database. You can select the probes, the networks that you want to start sending probes from, right? So it was enabling us to, you know, we were detecting an anomaly coming from networks X. We could use a probe there and start pinging stuff and doing trace routes and doing a lot of diagnostics. So we did that, and we did a few other things. But basically, we did a deep dive on the anomalies. So first of all, we kind of validate. We say, okay, so we think that in the vast majority of the cases, performance are identical. Is it consistent with what other people find? Because we didn't want to go to bark the wrong tree, right, and go on a tangent. And so the answer is yes. There are we found at least two pretty significant studies. One from APNIC, Dr. Houston, and the same that Tom mentioned, and another one from a university in Czech Republic that is also doing a lot of measurements. And they basically found that, you know, the numbers were slightly different, but it was like over 95% of the cases, the performance were within 50 milliseconds of one another or within 100 milliseconds of one another. So rather identical. And the exceptions were about the same. In the case of the Czech Republicans, they have a slightly higher number of IPv6 being broken, but that's because they also test IPv6 only sites, which happen to be test sites most of the time, and so don't necessarily work all the time because they're test, right? So basically, first type of anomaly, right? I hope you guys can see the graph, but basically we had a very significant number or proportion of cases where V6 was way better than V4. And so we were super interested. We said, wow, that's a sweet spot. Let's look at this, right? Finally, V6 is better than V4. We have something to sell here. Well, it turns out that, it was an anomaly and still is. But it's actually, that's the Hurricane Electric effect. So Hurricane Electric is by far the most popular transit system for IPv6. Right? They are way better in V6 than they are in V4. If you rank them, they are number 1 in V6, and there must be something like 25 in V4, right? And so they've enabled V6 everywhere, and they've been actively marketing V6. And what happens is, in particular, so most of the cases where we had this, not most of the cases, all the cases where we had this big premium to IPv6 was because the source was in Asia-Pac. The destination was in Europe, somewhere in Europe. And it turns out that a lot of service providers in Asia-Pac are actually peering with Hurricane Electric for IPv6 only. They don't peer for V4 with HE. They peer for V6 only. So basically what it creates is V6 goes this way, V4 goes this way. And it also turns out that Hurricane Electric is one of the few that have a cable, a direct cable from Singapore to south of Europe. Marseille in that case. So the problem was every single time we were using that cable, which was a much shorter path to go to the European website than the one going, you know, over the Pacific to the US, West Coast to East Coast, over the Atlantic and to Europe. 800 milliseconds. That's the difference. So path non-congruency is the answer, right? So the message here is, if you peer with a particular ISP for v4, you better peer with 4v6 at the same time, on the same link. Avoid creating those discrepancies, otherwise you may end up having inconsistent performance. Okay, so that was, and I have all the details, by the way. I don't want to go too much into, but that's the famous cable. Right? Second type of anomaly, the reverse, right? V4 was better than V6 by, anything between 200 and 400 milliseconds, and it varied quite a bit. And we found out that in the vast majority of those cases, it was, again, an issue with path discrepancy. In other words, and in that case, I don't want to point finger because that's an example. I'm sure it happens in other places. But in that particular case, it was Tata in the US. Basically, what they were doing is, our probes was in Virginia, right? Rack space. The destinations were a bunch of servers in DC. And the traffic with V4 was going straight from Virginia to DC. It's pretty close, right? But for V6, we were going through Dallas, right? Well, guess what? Dallas round trip, 200 milliseconds, not by plane. I'm talking packets here. So again, path discrepancy. So this time it was discrepancy within an ISP network, within an AS. But the problem is the same, right? Lessons learned here. So the performance overall are about the same. Okay, and that's good news. It's not bad news. It's by design. We want them to be the same, right? But it's good that we measure them. By the way, we're looking at measuring this ongoing and making the results available, but it's going to take us more time. We're not ready to do that yet. We did it over 3 months period, right? And did the report. The most performance anomalies, I mean, there are a few exceptions, but most performance anomalies are due to non-congruent path, right? One way or another, right? And I would say make sure that you're peering or dual stack. I think it's a bad idea to peer with a particular service provider for V4 and a different service provider for V6. It's a bad idea, right? Because it creates those kind of things, and they are actually pretty difficult to troubleshoot. And the number one thing is monitor performance for both protocols. It's a must-do. You cannot turn on V6 and just forget about it, because otherwise you end up with the Tata situation, right, where V6 may not be going the same path as V4, and you have no idea. And the reason why you have no idea, by the way, that users won't complain. There is these things called IP eyeballs that is taking care of selecting, quote unquote, the best path between V4 and V6 automatically, transparently to the user. It's embedded into the browser. It's embedded into a number of operating systems. So if you do a request for a website that has both a Quad A and a Quad A, the stack will take care of taking the best one. Within, I mean, it gives a little premium to V6, but that's anecdotal. So basically, don't rely on the users to be your whistleblower. They won't. Most of the users don't know that they're going over V6 or V4 by design. So you're going to have to monitor, and I know that there are other presentations about that later on during the conference, but that's very, very important. Right? So enough about measurement, forecast, and stuff like that. I want to go back to my to the original comment I was making on Tom's presentation. Right? So I've been trying for a while to explain why V6 is better than V4. Try to articulate a business case. And I ended up having a lot of difficulties to explain what an IP networks look like, and explain why V6 is different, right? So I came up with this. It's a very simplified way of representing the life in the packet, right? So when you go to a user to a server, from a user to a server, so the endpoint is on the left. Is that true? Yeah, left for you. And the server or the VM is on the right. And you go through all kind of hoops, right? VLANs, VRFs, NATs, application level gateways, all kind of stuff to get from one point to another, okay? Each of those, by the way, probably create a state. So if you have a state created for any given session, that means that you lose the end-to-end paradigm. You have to maintain those states. You have to send packets from time to time to make sure that the state is still up and up so that you can send packets the other way. By the way, that's the reason why the battery of the iPhone doesn't last for very long, because those applications continuously send packets to keep the NAT states up, right? So that Twitter can send you a tweet easily. So that's what an IPv4 looks like, yeah? Well, the end-to-end is long gone, right? The end-to-end, most of the time, starts at the PE of the MPLS VPN network and finishes at the PE on the egress, and that's it. Everything else. The other thing that most people forget is that when you do voice, video, and data on a network, most of the time, out of your device, you have multiple VLANs. The voice goes into a VLAN, the data goes into another VLAN, eventually the video goes over the third VLAN. Guess what happened? Those VLANs get put into different VRFs, so you create those parallel paths in the network, and if you want to have, for example, a phone talking to a soft phone on a PC, they end up being in two different VLANs. You have to go through an application level gateway to enable that communication. That sucks. This is what a V6 network looks like. You don't need those application level gateways. You don't need, I mean, you may need them for adding value, like, I don't know, accounting and, you know, making, adding interesting business value. But you don't need them just to enable communication. The communication system is being flattened out completely. And one thing that is very important in this model, which you may not see very well, as you can see, the address goes beyond the endpoint. Let me try to explain what I mean by this. One of the very interesting properties of IPv6 is that you can give multiple addresses to an endpoint. If you can give multiple addresses to an endpoint, you can give those addresses into different prefixes. And if you can have multiple prefixes on an endpoint, you can then use those prefixes to carry different applications. So now you don't need VLANs anymore. You have 3 prefixes, one for voice, one for data, one for video. You don't break the end-to-end model, but you can still differentiate based on the address. Beautiful, right? And you eliminate the need for multiple VRFs, mapping your VLANs into VRFs, going into application level gateways. Now if you want to talk from a telephone that sits into a prefix and a PC that sits into 3 prefixes, you just pick up the voice prefix and you communicate end-to-end. There is no need for an application level gateway. You don't need to involve the call control to do NATs between different VLANs, right? So you flatten out the entire architecture. Similarly, and this is what we represent on the left side, right? On the left side here, you have an address not by endpoint, but by service or by apps. Yeah? Comcast, as an example, is looking at, or Deutsche Telekom is a better example, is looking at doing this for voice, video, and data into the consumer market, right? Another interesting property of doing that, by the way, is that you can, by distributing multiple prefixes into a branch office, you can expose the uplinks. So imagine you have 2 ISPs connecting a particular office. One ISP will give you a prefix, the other ISP will give you another prefix. If you propagate those into the LAN, your device will select the prefix that they want to use depending on the uplink that they want to use. Voice this way, video that way, data this way, internet that way. It's just a matter of selecting the right source address. Yeah? Today, the way you do it with v4 is that you NAT all this stuff, and it's only the router that has to do policy-based routing to figure out, you know, which application should go where, which may not be the ideal way. So a lot of opportunities for innovation in how we roll out application onto IP networks. Similarly, if you go to the data centers, I have a few examples. I mean, a lot of them are not public, so I can't really talk about them, but there is one that is public, and this is Facebook. Facebook Deutsche Telekom is in the same category, by the way. 90% of the traffic in Facebook is within the data center or between data center. Only 10% is to the user. And 100% of the data center is already IPv6 enabled, right? And by the way, the piece that is growing is the internal traffic, not the external traffic. The external traffic grows by a factor of the number of new users that they have, the traffic in the back end, in the data center, is growing by an order of magnitude more, right? 100% of their data center infrastructure is also already IPv6 ready. That enabled them to roll out application in a completely different way. One example, a few months ago, they were looking at some back-end process-to-process communication, which was relying on UDP ports to multiplex. And they were running out of UDP ports. So they were working on a sophisticated scheme to try to reallocate those UDP ports really, really fast so that they were not running into race conditions and stuff like that. And one day, a guy said, well, we have IPv6, right? Why do we bother with those 16 bits? We have 128. So now they do multiplexing by using the lower 64 bits of the IPv6 address. It shows you how, and they decided to deprecate the old API, by the way, and move on to the new one, right? So it shows you that if you open your mind and look at the IP address not just as a way to extend the address space just because of the number of devices, but as a different way of rolling out apps, there are tons of opportunities to do a lot better with v6 than we do with v4. Don't try to mimic what you've been doing with v4 over the last 20 years with v6. Think outside the box, right? A bunch of other examples. I'm not going to go over all of them, but we can certainly talk. There is another one that is very interesting. I don't know how many of you have heard of a technology called segment routing. Not very many. Okay, segment routing is, I'm not going to go into much details, but it's basically something that is probably going to replace the MPLS control plane. Okay, the whole idea is that you carry your segment IDs which are being mapped onto label in your routing protocol instead of an additional control plane like LDP or SVPT. And this has a very interesting properties that we can carry IPv6 segments. And IPv6 segments are really interesting because instead of being limited to the 20 bits of an MPLS label, you now have 128 bits. You can insert it into an option header, and as of a sudden, you can carry it end-to-end. So think of your MPLS network being truly end-to-end, right? Your MPLS network will go, or the equivalent of your MPLS network, will go from your endpoint all the way to the server. And you can carry those informations back and forth. That's the reason why John Leddy from Comcast thinks that this is SDN done right. You now can carry application semantic into the header. Right? v6 enables you to do this kind of stuff and rethink the way you deliver applications. So the conclusion here is that, yes, sure, we need to deploy v6 and we need to continue to deploy v6 and we need to accelerate to deploy v6 for the internet, for bringing on new devices on the internet. It's driven by the large address space. But there are a bunch of other things that v6 can do for us that we would never be able to do with v4, right? So it's going to eliminate a lot of the costs and the operational costs as well as the capex that have been existing in networks and didn't provide much value, quite frankly. So with that, conclusion is that it's really the protocol for the Internet of Everything. What we mean by Internet of Everything is Internet of Things plus people plus processes plus data. We believe that it's a critical component of it. I want to thank, before we go to the question, there are 4 people that have been critical in building some of this. 3 of them are interns, by the way, so I want to give them the kudos. Hugo, Marcel, and Guillaume are interns that have been working with us. And Eric, you probably know that name at least. He's Mr. IPv6 Security, Dr. Eric Winke. And he was actually instrumental in building some of these models and some of these data. Thank you. Question? Any question? No question. Any questions? Okay. I guess I answered all of them already. Thank you.
Thank you, Alan. This was really good. Thank you. Okay, very good. We're ready, almost ready to go to lunch. Just a heads up, this afternoon we're going to come back at 1:30. We have 2 tracks, SDN track, which is going to be here in this room starting at 1:30, and the second track is IP track that's going to be on the 2nd floor. So you're going to have to go all the way down and then get the other elevator up to the 2nd floor. Okay, at lunch, lunch is going to be served outside. You're welcome to come back. We're going to have a student paper in this room. But before we do that, we have some awards to give.
Hi, for those of you who don't know me, my name is Scott Hogue. I'm a founding member of the Rocky Mountain V6 Task Force. At this year's conference, what we wanted to do was recognize the sponsors who have produced some particularly good products and services related to IPv6. And so we wanted to have an award for the best IPv6 product and the best IPv6 service, and we'd like to present those now. This was submissions by the vendors and then a selection committee that voted, and we chose what we felt like as IPv6 experts what the best product or service would be. So the first award I'd like to present would go to Cisco Systems for their Cisco Wireless LAN Controller system. Is there a representative from Cisco who could accept the award on their behalf? Maybe Elaine? Elaine? Yes, please. I'd like you to receive an award, and we'll take your picture as well. So for those of you at this conference this week, Cisco has provided a Cisco Wireless LAN Controller system, a 5508 WLAN controller that's being used at this conference. It's connected to our CenturyLink internet connectivity and providing V6 only and a dual protocol SSID for all of you. We felt that the wireless LAN controller was a great product because it has really good feature parity between V4 and V6 features. It also has a lot of V6 security, first hop security features implemented in the controller by default and a lot of other settings. And they're coming out with a 8.0 version which has even more IPv6 features and capabilities. So we felt like that product was outstanding, and we'd like to present Cisco with an award.
Thank you. Yeah, sure.
In terms of a service, there's many vendors that provide IPv6 capability services, and the services can be anything from consulting services to products with services associated with them. And we'd like to present this award to A10 Networks for their threat protection system. It's a DDoS and security protection system that involves their Thunder TPS hardware, but it's a system that provides large-scale, high-performance DDoS protection, matches certain signatures from a V6 security perspective of malicious IPv6 traffic, and blocks those. And so it's a protection system that combines a service and some on-premise product. So we'd like to present them the award. Somebody from A10 Networks here to accept the award. Okay, thank you.